In this video, we're going to be talking about operations with algebraic expressions. So we're going to start with one that doesn't involve multiplication or division, just addition and subtraction. Although, we do have this negative sign that's on the outside of a set of parentheses. So what I want to emphasize in this example is, first of all, when you have a negative on the outside of the parentheses, that has to apply to everything in the parentheses. And second of all, we just want to remind ourselves what it means to combine like terms and when terms are, quote, alike. So first we'll start by taking care of this negative. It's really common for students to sort of underestimate the importance of this set of parentheses. This negative is not only going to make the 2xy negative, it's also going to flip the sign of everything in the parentheses. So let's start by doing that. So we have 7xy minus 3x cubed plus y to the fifth, because none of these get changed. And then all of these, the sign flips. So we get negative 2xy, and then negative y squared, and then positive x cubed. Okay, so that's the first step. And now let's think about like terms. So when you're trying to figure out what terms go together, it's terms for their variables and the powers of the variables have to match exactly. Okay, so let's get some colors here so we can choose what matches. So let's take this red first. So for example, this is a single x and a single y. This is 3 x's, right? 3 copies of x, so that doesn't go with it. 5 copies of y, that doesn't go with it. A single x and a single y. Okay, so here, this negative 2xy and this positive 7xy, those are going to go together. Okay, let's get a different color. So now we go to the next one. 3 copies of x. And the coefficient out here is unimportant for this step until after you've already identified which ones go together. Okay, so this negative 3 doesn't matter for choosing what other term it goes with. It only matters for determining what the final answer is. So we ignore this negative 3 for now, just like we ignored the 7 to begin with. So we've got 3 copies of x, x cubed. 5 copies of y, those obviously are not alike. We already put this one with what it goes with, so that's not it. 2 copies of y, that's not alike. And then 3 copies of x. Okay, 3 copies of x, 3 copies of x, those go together. Okay, let's get ourselves a different color. So now we've got y to the fifth. Well, here we've got 2 copies of y, and it's a common mistake for students to think that these can go together, but they don't. Okay, 5 copies of y, this y to the 5th power does not go with y to the 2nd power. So this is what I meant when I say not only the variables have to be the same, these do have the same variable, y and y, no x's in either of them, but the exact powers also have to match. But 5 is not the same as 2, so that's not going to be a purple one. It's going to be something else by itself. Okay, so let me get my black pen back. So we put the 2 red terms together. 7xy and negative 2xy is going to give us a total of 5xy. And this is where the coefficients come into play, this 7 and this negative 2. They weren't important for identifying which terms go with each other, but they are important for figuring out what they are when you put them together. So 7 minus 2, that's 5, and we keep the letters the same. Now let's move on to these blue ones. Negative 3x cubed, positive 1x cubed. We don't see the 1, but when we don't see a number, it's an implied 1. So that's going to give us a total of negative 2x cubed. And then there's only one purple one, so that's y to the 5th. It doesn't go with anything else, it just comes down. And there's only one green one, so it just comes down as well. Now, this is a perfectly fine final answer. In general, you want to write polynomials with decreasing exponents. However, when you have x's and y's, that's not quite as important because it's hard to know which should come first. X cubed because x is alphabetically before y, or y to the 5th because the 5th is a higher power than 3. Or similarly, this one has x's and y's. Where should it go? So we're not really too worried about that, but we are worried about getting the correct terms with their coefficients and everything after you combine all of these terms. So some are like terms, like the red ones and the blue ones, but some don't have a match, and that's perfectly okay. All right, so let's do one more, and this one is going to have some multiplication. It's going to be slightly more complicated. So here we've got x plus 3 times 3x squared plus x plus 1. And we're hopefully familiar with the fact that when you have, if this were, for example, just a 2 instead of an x plus 3, we would distribute that 2 to everything in here. And that's sort of what we're going to do here. Except instead of distributing the x plus 3 to everything in here, what we're going to do is take the x and distribute it, and then take the plus 3 and distribute it as well. So we're going to break this up. We're going to break up that x plus 3 and then distribute. So break up, then distribute. So what's that going to give us? First, we're going to distribute the x. So let's just write this broken up as our first step. So I've just carried down my 3x squared plus x plus 1, and I'm going to distribute the x there. And then I'm going to take the second part of this plus 3, and it's important that I'm taking the sign as well, and I'm going to distribute that too. And hopefully we're a little more familiar with things that look like this. So we're going to take this x and multiply it to each one of these terms, and we're going to take the 3 and multiply it to each one of these terms, and then we're going to combine like terms if we have any. So first, let's think about what happens when we multiply x times 3x squared. That 3 doesn't change, and then x times x squared, that's going to give us a total of 3 copies of x, so x cubed. Similarly, x times x, that's going to give us x squared, and x times 1 is of course just going to be x. Now we move on to this one where we distribute the 3. So 3 times 3 will be 9x squared, right? 3 times 3x squared is 9x squared. Then 3 times x is 3x, and 3 times 1 will be 3. And now here we've got a lot of different terms with a lot of x's. So we need to identify which ones are like terms. So let's get a color back. Let's say green. We'll start with the first one. 3x cubed. So again, remember, we're ignoring this 3 for now. All we care about is this 3. We need x to the third power. That one's not x to the third. Nope, 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 nope. So this one is the only one of its kind. So let's get a different color. Oh, let's choose purple's fine. Okay, x squared. So we know we don't have to check this one. It's already got its own color. So x squared. Can that go with x? No, even though the variables are the same, it's not the exact same power, but it can go with 9x squared, right? We don't care about the 9. All we're looking at right now is x squared and x squared. This one doesn't have an x squared. This one doesn't have an x squared. Okay, new color. Let's take this ugly yellow here. So a single copy of x. This one also has a single copy of x, so they're going to go together. This one doesn't. So we need one last color. And this final 3 is going to get its own color. So let me get my black pen back here. And now we're going to go about actually combining these terms. This was the only green one, so 3x cubed just comes down exactly as it is. X squared and 9x squared. Remember, there's the implied 1 here, so this is 1 plus 9 is 10 copies of x squared. And then x with 3x is going to give us a total of 4x. And then this plus 3 is the only one of its kind, so it's also going to come down. So this is going to be our final answer.